Welcome to Academia. My name is Brian Madena and my colleague is Emmanuel Ambua. Today we are going to discuss about ways of establishing mode of operation of a bar converter relay load, whether it's CCCM or DCCM or a critical conduction mode, also known as transition mode. So the first method, as we discussed in the previous video, is by calculating the minimum current, that is I min. And the formula for I min is the one does not change, the one that we derived in the previous tutorials, and is given as follows. So this is the equation for I min, where alpha t is nothing but T on. This alpha t you can replace here with T on, but think this question like this is just okay. So first, we said in the previous tutorial that when we calculate I min and we see that I min, when I min is greater than 0 or has a positive value, we conclude that this is a continuous current conduction mode. And when we calculate I min and see that I min is less than 0 or has a negative value, we conclude that this is discontinuous current conduction mode. One thing that we did not show is that when you look at this, it's known as discontinuous because when you come to, we can trace this path above 0 and you're going to see that there's no continuity. So this is discontinuous current conduction mode. And then there's one mode that we did not talk about, and this is the critical conduction mode. Critical conduction mode. Known as CRM, or the other name is the transition mode. Transition mode, which is known as TM. So in this case, in this mode of operation, the value of I min, the minimum current, is nothing but 0. So the minimum current is 0. So that is going to be the critical conduction mode. So the other method of establishing the mode of operation is by calculating duty cycle by calculating alpha prime, which is the duty ratio for limit of continuous current conduction. Okay, so how do we calculate this? First, the limit, we know that the limit of continuous current conduction is when I min is 0. Okay? And therefore, from that equation whereby you are told I min is given by Vs over R into exponential alpha RT over L minus 1 over exponential RT over L minus 1 minus E over R. So equating this to 0, so we can equate this equation to 0, isn't it? If you equate this equation to 0 and take this onto this side, what you're going to remain with is Vs over R exponential alpha RT over L minus 1 over exponential RT over L minus 1 is equals to E over R. Then you can have this, we can take it this side, R over Vs, and this will cancel, so you go with that. So you're going to have exponential alpha RT over L minus 1 over exponential RT over L minus 1 is equals to E over Vs, isn't it? Some textbooks can represent E over Vs as G. But for us, in this case, we'll just proceed with E over Vs. So we can have this as, so we can cross multiply here such that we have alpha exponential alpha RT over L minus 1 is equal to exponential RT over L minus 1 multiplied by E over Vs. Then you can take this one that side, so we are going to have exponential alpha RT over L is equals to 1 plus E over Vs into exponential RT over L minus 1, isn't it? So then taking the natural logarithm ln of both sides, you're going to have alpha RT over L is equals to ln of 1 plus E over Vs into exponential RT over L minus 1. Okay? So then now, since it was alpha, because we equated to 0, so this is the alpha at the critical lemma, or rather the boundary, is going to be given by L over RT ln 1 plus E over Vs exponential RT over L minus 1. Okay? So this is the equation for the duty cycle for the limit of continuous current conduction. And so how exactly do we conclude that whether you're operating in continuous current conduction mode or discontinuous current conduction mode, or even in critical conduction mode? First, it is so obvious, the first one, that when the duty cycle that I'm given, maybe say the question has given me a certain duty cycle, if it is equal to the value that I've calculated for alpha prime, this means that I'm operating at critical conduction mode. Critical conduction mode. Okay, and I can sketch this as the way we've done previously. It's just at the boundary, so it's going to be this way. So this is the on period, so you can say this is T on, and you say this is T off. Okay, so our second situation is when alpha, say it's less than alpha prime. Okay, so what happens when alpha is less than alpha prime? We see that alpha is less than alpha prime, so we know that alpha is given by T on over T. So for alpha to be less than alpha prime, it means that the on period is reduced. Okay? So what it means is that the on period has been reduced, and therefore I'll say that my on period now, this will be my new on period, so this will be my T on, and then this entire time will be an off period. So we have a few time to charge, but a lot of time to discharge. So this means that because the circuit is same and the parameters are maintained constant, this means that we will charge normally up to here, but we don't have enough charge. Okay, we'll charge normally until this point and then start discharging here. But to realize, we are going to discharge until a certain point. Okay? But my T off is quite large, so I'll have to cross and come down as up to here. And not exactly which mode of operation is this? This then becomes discontinuous current conduction mode. This is DCCCM. Okay? So the third situation, my third situation is when alpha is greater than alpha prime. So what exactly it means, alpha it's T on over T. And when alpha is greater, that means T on is large. So the on period, now my new on period will be, I say, somewhere here. So I'll have a very large on period here. Okay? And a very short off period here. Okay? This one is for a constant switching frequency. So I will charge, my inductor is going to charge, my current is going to charge here, and it's going to exceed here, and then it will have a very little time to discharge. See here. Okay? Similarly here, it's also going to charge. It's also going now to charge from here, say up to there, and then discharge. So which mode of operation is this? This is the continuous current conduction mode. So in summary, what I can say is, so to summarize exactly what we've done today, we can conclude that when alpha is equals to alpha prime, we have the transition mode, which is also known as the critical CRM, critical conduction mode. And when alpha is less than alpha prime, we are going to have what is known as discontinuous current conduction mode. And when alpha is greater than alpha prime, we are going to have continuous current conduction mode. Okay? So in the next video, we'll see how we can determine mode of operation based on extinction time. Please don't forget to subscribe to East Academia and click on the bell icon to get posted and be updated on our new videos. Thank you.